So in this video, in the second part of the video, let's see how do we solve systems of um, inequalities. So in the previous video, we took a look at how do we solve inequalities, right? Just one equation, not many, just one inequality. And in this video, we're going to take a look at how do we solve system of inequalities. So here you have more than one, as you see here. So here's one and here's another one. So we have two of them, and here's another example where we have two of them, and here's another example where we have four of them, right? We have four of them, and here's another example where we have four of them. So how do we solve these things? Again, when we try to solve this, so this is that we are trying to find the common area. We're trying to find the common area or that satisfies these two together. These two inequalities together. As I said earlier, the way that we're going to do is the same way we did earlier, but then now we have two constraints or two conditions. We need to make sure we need to find an area that satisfies these both of these inequalities. So for example, let's just say you have two circles, you have one circle here and you have another circle here. You are interested in finding the solution that is inside both of them, right? That means that it's going to be this particular one. And then let's just say you have a parabola and you have a line. You are interested in finding the solution set for inequality, one that is above the parabola, something like that, and below the line, right? Below the line. So then we are looking at the common area being this one as the common area, right? So these are the things like that we are trying to do in this particular set of inequalities or system of inequalities. So let's take a look on how do we solve these things. So again, as usual, we're going to do just like we did last time. We're going to graph the functions from here. So in this case, for example, the equation that I would get here is y is equal to x squared minus 4, which is a parabola, by the way. And this is a line. As we said earlier, we always like to keep the y being positive. So if you write the y being positive, the equation that I would get here is something like this, which is y is equal to x minus 2. Y is equal to x minus 2 is the equation that I would have. So let's take a look at how things are, or what do you mean by the things are here. So therefore, the first one, if you try to graph the first one, is a parabola. That's a standard parabola with the four units down. So it's going to look like this. It's going to be 0 at this point, and when x is equal to 1, it's going to be negative 3. It's right over here. When x is equal to, it's a 0. So again, so it's going to be here, it's going to be over there. When x is equal to 3, that's going to be 5. So it's right over here. When x is equal to negative 3 is also going to be 5. So here is the parabola, right? Here's that parabola. It's going to go like that. So that's the first one. And since this one says y is less than or equal to, y is greater than or equal to, so therefore here the region that we are interested in is going to be above the parabola. So anything on top of the parabola would be the set of values of x and y that will satisfy that inequality. The second one is a little tricky. What do I mean by that? This one is a little tricky. Although I write the equation this way, so I need to rewrite this inequality in terms of with the y being positive. So for us, it's easier for us to do it, right? Let's try to write it. So if you rewrite this inequality with the y being positive, right, what I'm going to have is I'm going to have y less than or equal to x minus 2. Y less than or equal to x minus 2, because this is easier for us to see. So now this means that anything below this line, that means that anything below this line. If you just keep it this way, sometimes it might be harder to look at things like that. So let's take a look at y is equal to x minus 2. When x is equal to 0, y is minus 2, so it means it's right here. When x is equal to 2, y is equal to 0, so it's going to be right here. So this is this particular line right there, right? So it's going to be this particular line right there. And I'm just extending it, right? So as I said in here, if I rewrite this equation, this is y is less than or equal to x minus 2. So it's going to be everything below, right? So everything is below. So we are looking at this right here. Everything is below. We are looking at this right here, and so therefore the therefore the region that we are interested in, is going to be, so everything below. So therefore the region that we are interested in is going to be this particular region, above the parabola and below the line. So that is the solution, the region of the solution. So any point in here will satisfy both of these inequalities. Let's take a look at another problem in here. X squared plus y squared is less than 4, and y minus x squared is greater than or equal to 0. Again, this is a circle. This is a circle of radius 2, right? If you write it. And this is a parabola. So again, as I said earlier, I always like to write y greater than or equal to x squared. That kind of tells me is it above or below and so on. The first one is circle of radius 2. So it's going to be 2, 2, negative 2, negative 2. So it's going to be this right here. The second one is parabola y is equal to x squared. Y is equal to x squared is going to be 0, 1, and 4, and then 9, and 1, 4, 9. So the second one is going to be this one right here, and this one right there. Now again, so circle is, since it's less than, since this is less than right here, what do you see here is a less than 4, so which means everything is inside the circle. So which means we are looking at, this region right here for the first inequality. The second inequality is, here is y is greater than or equal to x squared, which means everything is above the parabola. So it's going to be this particular one right here. It's going to be this particular one right here. So the common region here is this one, and so therefore that is the region of the solutions. So that will be the region of the solutions for that particular problem right there. All right, let's take a look at the next set of ones. How do we do this particular one? So here we have 4 constraints. The first one is x greater than or equal to 0. Here is the, here is the line y is equal to, here is the line. That is x-axis is y equal to 0. So this is the line y is equal to x. This is the line, sorry, x equal to 0, which is the y-axis. X greater than or equal to 0 means everything to the right of this line. This is the line where x is positive. And what is the meaning of y is greater than? So this is the one that corresponds to that one. And what is the meaning of y greater than or equal to 0 is everything above the x-axis. It's going to be, this particular one. Right, so that corresponds to this right here. And let's take a look at these two, right? So let's try to graph these two lines and see what happens. So if I rewrite this as an equation, so I can graph it. This is 2x plus 5y is equal to 10. If I rewrite this one, this is 3x plus 4y is equal to 12. So what I'm going to do, I'm going to again plot 2 points, so that way I know the lines. When I plug in y is equal to 0 in here, when I plug in y is equal to 0 in here, this is 0. So therefore, I would have 2x equal to 10. That means that x is equal to 5. So I have the point 5 comma 0. Another point is when I plug in x equal to 0. When I plug in x equal to 0, that means y is equal to 10. That means that y is equal to 2. So what I have here, I have another point which would be 0 comma 0 comma 2. So let me graph these 2 points. What I'm going to have is I am going to have 5 comma 0 is right here, and 0 comma 2 is right there. So here is this line. This line is gonna go like that, right? And that is this particular line right here. Let's change and let's take a look at the second line. This line again by the same token earlier, when I plug in x equal to 0, that gives me 4y is equal to 12. That means that y is equal to 3. So x is 0, y is 3. X is 0, y is 3, which is going to be this right here. And the second one, when I plug in, when I plug in y is equal to 0, when I set this equal to 0, that tells me 3x is equal to 12. Since 3x is equal to 12, that means that x is equal to 4. So x is equal to 4, y is equal to 0. It's going to be this right here, right? Which means that right there. So here is this line. All right, so that's the line right there. Now let's take a look at all these conditions, right? So both of these are, y, positive y here, which is less than there, right? Positive y here, which is less than over there. So that means it's below these two lines. So we are looking at, below this line. We are looking at, below this line. And it's maybe harder to see. So basically what I'm trying to say is that I will zoom it out in a moment. So this corresponds to that line there, and this corresponds to that line over there, and everything is below. So therefore what I'm going to have here is I'm going to have something like this, right? So one of them is going to be here. The other one is here. Let me change it to a different color. The other one is going to be over there. So it's going to be here. So if you take a look, the region for the solution to be satisfied in this case is going to be this particular one. Basically, this, let me use a different color. Let me go with the green. This, and this. So the solution, right? Region of solution is going to be this particular one right there. You see that is above the x-axis, to the right of the y-axis, and below these two lines, right? And that's how we find the solution. That's how we find the solution to this system of inequalities. That's the same way. I'll let you do these problems on your own. This is the B is also a very similar way to do that one. And here's your it's your turn problem. That completes the section 5.5. In the next video, we'll take a look at how do we solve linear programming. This is very similar to what we just did earlier, except that we're going to solve some wonderful, awesome problems. All right, I will stop it here. I'll see you.